Hello everyone. Today we want to talk about 10.5 comparison tests. There are two comparison tests in 10.5. In this lecture, we will talk about the direct comparison test. In the next lecture, we will talk about the limit comparison test. So here's the idea. Both comparison tests use known series to test the convergence of unknown series. So notice that right here, the unknown series is the series in the problem. Series from the problem. Okay, and in the box below, we will use summation of AK to denote the series from the problem. It is also the unknown series. And the known series is the series we choose. And in the box below, we will use summation of BK. So that means you will need to choose a series to compare with the series from the problem. And right here, usually, this is S. Okay, usually, we will choose geometric series or P series. Because for geometric series and P series, we know the convergence of this series. Right? For geometric series, we just need to take a look at the ratio. And for P series, we just need to take a look at the p-value. Okay? So first, let's take a look at the comparison test. Suppose summation of AK and summation of BK are infinite series with positive terms. Okay, this is important. You have to make sure that every term is positive. Okay, so if you have some alternating terms, okay, some terms are positive, some terms are negative, then you cannot use the comparison test. Okay, so right here, let me write down the conclusion first, and then I will do some explanation. If A sub k is less than or equal to B sub k, and summation of BK converges, then summation of AK also converge. Okay, summation of AK also converges. Now, if AK, A sub k is greater than or equal to B sub k, and summation of B sub k diverges, then summation of AK also diverges. Okay, so if you look at the description, okay, it seems like it's really difficult to understand, but the concept is really, really easy. Okay, so let me try to explain this by using some, not really an example, but some stories. Okay, let's try to use some stories to explain what's going on right here. Okay, so notice that comparison tests use known series. Okay, so we need to find some series we know, like geometric series or the P series. Okay, to test the convergence of unknown series. Okay, so we have an unknown series, we have a known series. Okay, so right here, because we let summation of AK to be unknown, so let's say this AK, okay, this AK is my monthly payment. Okay, so how much I get from my work every month. Okay. Now right here, okay, because that's unknown. Okay, that's unknown. Okay, we will need to pick some series we know to compare with. Okay, so right here I will pick BK as the, let me write it here, monthly payment of Peter Parker. Okay, so right here, I'm talking about the Spider-Man, like a long time ago, not really a long time ago, but you know, Tobey Maguire's Spider-Man, okay, that Peter Parker. I don't know if you have seen that movie before, but in that movie, okay, Tobey Maguire, that Spider-Man, Peter Parker, works really, really hard, but he can hardly afford his rent. Okay, so he's really, really poor. Okay, so notice that summation means the sum. Okay, so this inequality right here means my monthly payment is less than or equal to Peter Parker's monthly payment. And I know Peter Parker is poor because in that movie, okay, he works he works three jobs, okay, but he can hardly afford his rent, okay, so he's poor. Now, if I earn less than Peter Parker, then I will be poor, right? So summation of BK converges. So that means the sum, okay, the sum is a specific number, okay, and then of course the sum of my monthly payment will be a specific number as well because I earn less than Peter Parker. Okay, now similarly right here, that AK be my monthly payment, and that BK, okay, that BK be the monthly payment of Bruce Wayne. Bruce Wayne. Okay, so right here, it doesn't matter which Batman movie you're talking about because in all Batman movies, Bruce Wayne is super rich. Okay, so now take a look at this. My monthly payment will be greater than or equal to Bruce Wayne's monthly payment. And Bruce Wayne is rich. Okay, so notice that sigma, summation, means the sum, right? So if you add all his monthly payment together, it will explode, right? So diverges, okay, because he's rich. Okay, if I earn more than Bruce Wayne, and then Bruce Wayne is rich, then I am super rich. Okay, again, if I earn less than Peter Parker, and Peter Parker is poor, then I am super poor. Okay, so that's the idea for comparison test. So that's why I say this is not really an example. Okay, it's kind of like a story, but the concept is the same. Okay, you want to find somebody to compare with, right? Of course, you want to find someone you know. Okay, you want to compare with Peter Parker. You want to compare with Bruce Wayne. Okay, for example, you don't want to compare with my friend. You don't even know who my friend is, right? So you want to find somebody you know to compare with. Okay, so let's go back to the math. Okay, let's go back to the math. If the term AK is less than or equal to the term BK, and summation of BK converges, then summation of AK will converge. If the term AK is greater than or equal to the term BK, and summation of BK diverges, then summation of AK will diverge. Okay, now here we have a note. If the term AK is less than or equal to the term BK, and summation of BK diverges, then what can we say about summation of AK? Now, if you use this story, it really makes sense. Okay, so my monthly payment is less than or equal to Bruce Wayne's monthly payment. Okay, right here I choose Bruce Wayne, not Peter Parker, because right here it says that summation of BK diverges. Okay, so that means this guy's fortune, okay, is, well, a lot. Okay, so he has a lot of money. Okay, so that's why here this is Bruce Wayne. So if I earn less than Bruce Wayne, and Bruce Wayne is rich, what can you tell me about me? Well, I can be rich, right? Just not that rich. Or I can be poor, right? So we really don't know what's going on right here. Okay, so again, if I earn less than Bruce Wayne, and I know Bruce Wayne is rich, then do you know how much I make? No, right? Because to be honest, everyone earns less than Bruce Wayne, right? Okay, so right here, the comparison test is inconclusive because it cannot tell us any information. Okay, now right here you see that summation of BK converges. Okay, so I will choose BK to be Peter Parker. Okay, so if I earn more than Peter Parker and Peter Parker is poor, then how much do I make? Well, we don't know, right? Because I can be rich, I can be poor, right? Because in that movie, everyone earns more than Peter Parker, right? Okay, so right here, the comparison test is inconclusive. Okay? Okay, so we will talk about how to use the comparison test later. Let's take a look at example 1. Suppose we want to use the direct comparison test to determine whether the series converges or diverges. Which of the following statements is true? Okay, so notice that in order to use the comparison test, okay, it doesn't matter if it is a direct comparison test or a limit comparison test. Okay, as long as you use the comparison test, you need to pick a series to compare with. Okay, just like here, you need to pick a guy to compare with. Okay, so notice that this is the series from the problem, so this is unknown. So we will pick a series which we know to compare with. Then you might be wondering, then how do I pick that series? Okay, I know that you say we want to pick a geometric series or a P series, but which P series or which geometric series do I need to pick? Okay, that's a very good question. So let's take a look at the series right here. Okay, so notice that when this k goes to infinity, this negative 1, right, this minus 1 is almost nothing. So that means the term, okay, when k goes to infinity, the term will behave like k over cubic root of 2k to the 6. Okay, so that is the series you want to pick. Okay, that is series you want to pick. Okay, so now notice that I want to compare k over the cubic root of 2k to the 6 minus 1. I want to compare this unknown series. Okay, of course, I want to compare the term. Okay, terms. Okay. This term is from the unknown series. I want to compare, excuse me, with the term from the series I pick. Okay, and I pick k over cubic root of 2k to the 6. Okay, again, as I mentioned earlier, when k goes to infinity, this negative 1 is almost nothing. Okay, so we want to compare this guy with this guy. Okay, so if you take a look at the previous box, okay, after we pick somebody, okay, we pick Peter Parker or we pick Bruce Wayne, we need to establish this inequality. Okay, we want to know who earns more, right? I earn more or Peter Parker earns more. Do I earn more or Bruce Wayne earns more? Okay, so we want to create this inequality. So right here, we have two fractions. And you can see that the numerators are the same. Okay, so let's take a look at the denominators. Okay, take a look at the denominators only. Which denominator is larger? Right, this one, right, this one, right, because this is 2k to the 6 minus 1. 2k to the 6 minus 1 will be less than 2k to the 6. Okay, so this is a larger denominator. and this is a smaller denominator. Okay, now if you I don't know if you remember, but I think previously we talked about something like this. We say that if you have a smaller denominator, that means the value of your fraction is larger, right? So think of 1/2 and 1/3, right? 2 is smaller than 3, but 1/2 will be greater than 1/3, right? So a smaller denominator will give you a larger value. Okay, so right here we have a greater than. Okay, we have a greater than. Okay, so you're looking for greater than right here. But you notice that, wait a second, this guy is not the same as this guy. Okay, that is because right here we can try to simplify it. Okay, so we still have a k on top, and right here I can separate these two numbers. So I can have the cubic root of 2 times the cubic root of k to the 6. Okay, the cubic root of k to the 6. Okay, now of course, if you know what to do, you can finish this within one step. Okay, and notice that the cubic root of k to the 6 is k to the 6 over 3. Right? We use exponential laws. Right? This is the cubic root means 1/3, the power of 1/3. So 6 over 3. So that means that will be a k squared. Okay, and finally you divide both top and bottom by a k to get 1 over the cubic root of 2 times k. So that's why you see here we have 1 over the cubic root of 2 times k. Okay, now if you are doing this problem on your own, okay, notice that, okay, it's very difficult to come out this really soon. Okay, you cannot see this is 1 over the cubic root of 2 times k. Well, I cannot see. Okay, so the best way is to think of k over the cubic root of 2k to the 6, and then you do simplification to get this result. Okay, so we are looking for greater than. So this is less than, so don't choose it. This is less than, don't choose it. Okay, so greater than, good. Well, this is a little bit confusing because it looks like equal. Okay, so this, yes. How about this? Yes and yes. Okay. Now this is the series we pick. So notice that this is not a series. This is a single term. Okay, so the series we pick should look like this: summation of 1 over the cubic root of 2 times k, and k star from 1 to infinity. Okay. So we will choose this series to compare with. Okay, and notice that right here, the cubic root of 2 is a constant multiple, so I can take it out. Okay, so this guy becomes 1 over the cubic root of 2 times summation of 1 over k. Okay, summation of 1 over k. But what kind of series is summation of 1 over k? Good, this is a p series with p equals 1, right? Or you can say this is a harmonic series. Okay, so this is a p series with p equals 1. Okay, or you can say this is a harmonic series. Okay, so this is a p series with p equals 1, and we know that if p equals 1, then this series diverges. Okay, this series diverges. Okay, I need some space, so I'm sorry. It's like a hide and seek. Okay, so this is the first part, this is the second part, and I put the third part right here. Okay. So the series we pick is divergent. Okay, and we know that our term is greater than the term we pick. Okay, the series we pick is divergent. That means this guy is Bruce Wayne. And we earn more than Bruce Wayne, right? Because that's a greater than. That means we earn more than this guy we pick. Okay, we earn more than Bruce Wayne. And Bruce Wayne is rich. So that means we will be super rich. Okay, so therefore, the original series the original series also diverges. Okay, also diverges. Now, don't forget, you need to mention the name of the test. Okay, so this series diverges by the comparison test. Okay, if you want, you can say direct. Okay, by the direct comparison test. Okay, or just simply comparison test. Okay, any questions? Okay, so if you have any questions, please do not hesitate to email me. Okay, so sorry, I think we have to choose A. Okay, the series diverges. Okay, the series diverges. Okay, so let's take a look at page 2. Okay, if the series we choose is divergent, okay, if the guy we choose is Bruce Wayne, then we want to make more than Bruce Wayne, right? So we want AK to be greater than or equal to BK. We want our monthly payment to be greater than or equal to Bruce Wayne's monthly payment. Okay? Now, if the series we pick is convergent, okay, so this guy is Peter Parker. That means I want to earn less than Peter Parker. Well, I don't really want to earn less than Peter Parker. What I mean is, in order to get a conclusion, right, I need to make less than Peter Parker, right? So the comparison test will tell me, yeah, you are super poor, okay? Because if I earn more than Peter Parker, then the comparison test will be inconclusive, okay? Does that make sense? Okay, so take a look at here. Okay, so if the series we pick is convergent, then we want AK to be less than or equal to BK. If the series we pick is divergent, we want AK to be greater than or equal to BK. Okay, so let's take a look at example 2. Determine if the series converges or diverges. Okay, converges or diverges. And you can see that this is a free response question. Okay, so we don't have anything to compare with. Okay, so we will start from scratch. Okay, so notice that right here we have cosine. Okay, we have cosine, and well, we have cosine square. Okay, we have cosine square, and we know that cosine square will always be between 0 and 1, right? 0 and 1. So right here, for any positive integer n, your cosine square of n will always be between 0 and 1. Okay, I don't know what your input is, but I know the smallest value will be 0 and the largest value will be 1. Okay, of course you can have 1/2, 1/4, 1/5, anything else, I don't care. Okay, it's always between 0 and 1. Okay, and notice that right here, our numerator is cosine square plus 3. So that means cosine square plus 3 will always be between 4, because I add 3 in the middle. So I will add 3 right here, and I will also add 3 right here. So your numerator is always between 3 and 4. Now notice that I want to divide cosine square plus 3 by a to the n. So I will do this for every term. So cosine square of n plus 3 over a to the nth power will now be less than or equal to 4 over a to the nth power and greater than or equal to 3 to the 3 over a to the nth power. It's okay? Does that make sense? Because cosine is always between 0 and 1. So that's why we have this inequality automatically. Okay? Now it looks like we have 3 series right now. Okay, so this is the series from the problem. Okay, and these 2 are the series for my upper bound and lower bound. Okay, so but right now I don't know which series I want to pick. Okay, I know it should be this series or this series. Okay, but I don't know which one I want to pick right now. Okay, but let's take a look at this together. So if I want to create a series, this becomes 3 times summation of 1 over a to the nth power. Right? And this is 4 times summation of 1 over a to the nth power. It's okay? This n. And notice that they are both geometric series. Okay, they are both geometric series. Okay, and their ratios. Okay, they both have the ratio of 1 over 8. Okay, so these are geometric series where the ratio is 1 over 8. And notice that 1 over 8 is between -1 and 1. So that means they both converge. Okay, they both converge. Is okay? Good? Okay, so notice that right here, if the series we pick is convergent, then we want AK to be less than or to BK. So that means right here, we should use this inequality. Okay, we should use this inequality. Okay, now let's just take a look at the other one. Let's say we use 3 over a to the n less than or equal to cosine square of n plus 3 over a to the n. Now this is convergent, right? So that's Peter Parker. And I earn more than Peter Parker. So what can you tell me about me? Well, again, in that movie, everyone makes more than Peter Parker, right? So we don't really know what the comparison test can tell us, right? So the comparison test will be inconclusive. Okay, so that's why we don't use this inequality. Okay, now notice that right here we use this inequality, so we earn less than Peter Parker, and Peter Parker is poor. That means we are poor. Okay, does that make sense? Okay, so right here, so we will use cosine square of n plus 3 over a to the n less than or equal to 4 over a to the n. Okay, we will use this inequality. Okay, and okay, we use this inequality, and since 4 times summation of 1 over a to the nth power, okay, is convergent. Okay, of course we explain we explain right here, so we don't have to explain it again. And since this series we pick is convergent, it follows that the original series is also convergent. Okay, is also convergent. And don't forget, you need to say the name of the test. Okay, so by the direct comparison test. Okay? So again, for comparison test, it doesn't matter if you're using the direct comparison test or the limit comparison test. You need to pick a series to compare with. Okay, so you need to create a series. Okay, the problem will not tell you, hey, pick me, pick me. No, you will need to create that series on your own. And remember, we always want to pick either a geometric series or a p-series to compare with. Okay, because they are easy. Okay, for geometric series, you see here, we just need to see what R is, and then we know about the convergence or the divergence, right? And here for p-series, we just need to look at the p-value, and we will know about the convergence or divergence. Okay, so we usually pick a geometric series or a p-series to compare with. Okay, and once you pick the series, you will establish an inequality. Okay, remember, you want to earn more than Bruce Wayne, and you want to earn less than Peter Parker for the comparison test to work. Okay, so I hope this story, okay, not examples, I hope this story can help you understand the concept better. Okay, and there are more practice problems on Canvas. Okay, make sure you practice all of them. Okay, and also problems on the old test on the 1080 website are also important. Okay, don't forget to practice them. If you have any questions, please do not hesitate to let me know. Thank you.